Today I'll be talking about the absolute value in math, and the definition out of a textbook looks something like this. So these are the absolute value bars. So this is telling you absolute value of blah blah blah. In this case, it's the absolute value of x. And the standard definition looks something like this out of a textbook. So all this means is that our number on the inside is positive when the inside number is greater than or equal to 0, and the number inside is negative if the number inside is less than 0. And why is it important to know this? Well, that's because if we have a positive number, the absolute value of a positive number like 2 is just the same number. It's just 2, right? And the absolute value of a negative number is also 2. And this is because the absolute value is asking you how far away each number, or what number, in this case I have 2, right, that I'm going to showcase, but it's asking you how many units is this number away from 0? How far is this number from 0? And they're both the same distance from 0, right? They're both 2 units away from 0. 1, 2, right? They're both the same distance. That's why their absolute value is the same, 2 units. So another way you can simply look this, look at this way as if any negative number, when you take the absolute value of it, is just positive that number. So negative number, take the absolute value, it becomes the same number but positive. It makes that number positive. That's another way teachers also like to just say it, because this isn't that it is very important to know this definition, because knowing what numbers on the inside matters. But in algebra, from what I remember when I was learning it, didn't really matter all too much if you remember this definition. But it's good to keep in the back of your head for future use. And right now they're talking about some properties of absolute values. So an absolute value, A, it'll always be greater than or equal to 0. And all this is saying is that whatever number you put in here is always going to be positive. That's all it's going to say, right? Because they're both positive, and 2 is obviously bigger than 0, right? So this property is just telling you that any number you put in there, whether it's negative or positive, will always be bigger than 0, or equal to 0 if it's 0 itself, right? The second property I'm going to be talking about is if you have two numbers multiplied, right? Right. This means multiplication of A and B. You can split it apart if you want, and just take the absolute values of each separately. I don't know why I wrote another A there. Maybe rewrite that real quick. Right. You can just split them up and do them separately if it makes it easier in whatever case you're in. And if you have something like this, A plus B will always be less than or equal to A absolute value plus the, right? Yeah, this is also called the triangle inequality. It's just a property you should remember. So whenever you combine two numbers, so with addition, right, it's always going to be less than or equal to whatever it is if you just take them separately. And I can try and think of it. Yeah, I can showcase this real quick. If you have, let's say you have 5 plus -3. Right, this is just subtraction basically. Your answer is going to be 2, right? Which is just 2. And if I take them separately, right? And taking them separately, the absolute value of 5 is just 5. The absolute value of 3 will become positive 3, right? And that becomes 8, right? And 2 is obviously less than 8, right? This is true. So that's why this formula, this property is true. That's just a quick example. Another property that I already explained is that any negative number that you put inside an absolute value just becomes that same number positive. So we can both say that these two are exactly the same, right? -2, the absolute value of -2 is again equal to the absolute value of 2. This is always true. And the last property that my book here is showing me, oh no, wait, there's one more. But the second to last property is A divided by B. Absolute value of that is equal to this. Again, just like multiplication, you can split the absolute values apart when you're dividing, or you can take the absolute value of the top and the absolute value of the bottom separately if you want. If that makes it easier for the problem you're working with. And the last property is that a number that you don't take the absolute value above will always be less than or equal to the absolute value of the same number, right? So like if we have a negative number, it's going to be less than its absolute value, right? Because -3 is obviously less than 3, right? So this is true. That's all this property means. Next, I'll be talking about how to find the distance between 2 points using absolute values. So this is the formula, I guess, you can remember when we're finding the distance between points A or B, right? So these will give you the exact same answer, the distance between these 2 points on a number line. And an example is if we have -5 and 3. If I asked you to find the distance between this number and this number using absolute values, you would call either one of these, you would give one of these a value of whatever value you want to pick for them. So I'm just going to call this A. We're going to call this variable A, right? And this guy we're going to call B. So now we're just going to put them in their proper place. So we're going to have the -5, right? Because I'm saying that A is this guy. So I'm just going to put -5 in the place of A. And I'm going to put 3 in the place of B, which is subtraction. Right? Oh, what am I doing? You take the absolute value of that. And then you do the operations inside like how you would normally do this. So you would have -8, but you keep the absolute value bars, and now you take the absolute value, and you're left with 8. So we can say that the distance between -5 and 3 is 8 using this formula here. And if we do it the other way, if we put 3 minus this, we'll get the same exact answer. So I'm going to put 3 in front, and we're going to subtract the -5 here. Remember, when this is basically just addition, because we're basically just kind of multiplying this. If we put them in parentheses, right? Negative times a negative. So we're going to get a +5. Add them up, get an 8 absolute value bar, and left with 8. It's the exact same answer. And you can test this with the number line if you're still not sure. So we have a 0, -5, -4, -3, -2, -1. This is a really bad number line. If you count them 1, 2, 3, 4, 5, 6, 7, 8. So they're 8 units apart from each other. So we can say the distance between -5 and 3 is 0. That's really all you need to know for now, what absolute values are. And yep, that's about it.